So this will go through the review. I don't know. The first time I recorded the video, it didn't record sound, so the video doesn't have any sound. So I'm actually recording a video of the video. So while we talk, it's recording the sound. And so it'll be a second video of the first video while we watch it recording the sound. So we'll see if that works. I'm not too old. But anyway, on the first three, when you're trying to figure out which one is which, you need to make sure that you label the ones that are, A, B, and C need to be in order. Not necessarily A and B, but C definitely needs to be the biggest or the longest side. And so some people got confused over when it was a cube. So when C squared is bigger than A squared plus B squared, that means that or when it's smaller, that means that the hypotenuse is too small, or that third side is too small to be a hypotenuse. So if it's too small to be a hypotenuse, then it won't be a right triangle. It'll be a acute triangle. If it's too big, like the third one, if C squared is too big to be a hypotenuse, then it'll be an obtuse triangle. On 2 and 3, these are where we would use the Pythagorean theorem. We don't know any angles, so we can't use the 30, 60, 90 or 45, 45, 90 rules. We can really only put these into the Pythagorean theorem. We know 2 of the 3 sides, so we just label them A, B, and C and plug them in where they're supposed to go, and then solve for the one that's missing. The only difference between number 2 and number 3 is that on number 2, the hypotenuse is missing. On number 3, one of the legs is missing. So it just means whether you would end up subtracting or adding to get the one that's missing by itself. There's a review back there, Taylor. On these, on 4, 5, and 6, just like on 1 and 2, we're going to use the rules that we had on number 1 to decide. So we need to label it A, B, and C, and then we need to look and see if, since 18 is our biggest side, we need to compare 18 squared to 12 squared plus 14 squared. The 12 squared plus 14 squared was bigger, so what could have been the hypotenuse is too small to be a hypotenuse. It means it's going to be an acute triangle instead. Number 5, they don't put them in order, so you got to be careful about that. 50 is going to be your potential hypotenuse. We got to compare 50 squared to 14 squared plus 8, 48 squared. Both of those have the same value, which makes this a right triangle. And I think on number 6 actually is a little bit of a trick, because 6 actually won't make a triangle at all. Remember our rule where the 2 smallest have to add up to bigger than the biggest? Well, 14 or 16 and 24 adds up to 40, and the other side adds up, and the other side is supposed to be 42. So not only is it too big to be a right triangle, it's too big to be a triangle at all. I put obtuse, and that's going to be fine, but it's not really obtuse. It's not existent. It's not really a triangle at all. 7 just wants to know, is it a right triangle or not? So you do it just like 4, 5, and 6, but all you have to tell is whether it's the same or not. If it's If c squared is exactly the same as a squared plus b squared, then it's a Pythagorean triple. It makes a right triangle. If not, then it is not. 18 squared plus 24 squared is the same as 30 squared, but not number 8. 5 squared plus 8 squared is just 89 versus 121. So note, that's not a Pythagorean triple. On number 9, we're looking for EG, which is a diagonal of this rectangle. So if it's a rectangle, we have 4 right angles. So we just look at half of this thing. We just look at triangle EGF. We've got 2 legs of a right triangle, and we're trying to find the hypotenuse, which would be the same as the diagonal of the rectangle. We just plug this into the Pythagorean theorem where we let the diagonal be our hypotenuse. We just take the square root of 9 squared plus 12 squared. So the diagonal is 15. Now we have a problem we've looked at before. We've got 2 different ways that Miss Benson can get from the house to the airport. She could take Airport Road, which is a straight shot, or she could go Mountain Highway over and then Oak Road up. In order to figure out how much distance she'll save by taking the straight shot Airport Road, we got to figure out how far it is along Mountain Highway. So plug it into the Pythagorean theorem. Let the Oak Road distance be A. Let the Airport Road distance be our hypotenuse length. And then the Mountain Highway Road would be our B distance. Square root of 65 squared minus 25 squared is just 60. So if we take Mountain Highway, then Oak Road, we end up going a total of 85 miles, as opposed to going the straight shot 65 miles. So we would save 20 miles by going Airport Road. All right, here on number 11, we're trying to find out how far it is from L to M. And even though it looks like it might be the whole thing might be a right triangle, and it could be, we're not told, and we don't know how to figure that out yet. But what we do have is 2 right triangles that are kind of backed up against each other. We got a little bitty one standing up, and then a big one, and this one in blue is the big one that's laying down. Okay, so if we can find the distance from N to M, which is along that downside of the big blue triangle, and then we can find the distance L to N, which is the short leg of the little red triangle. We add those 2 together, we'll get the whole thing. So we'll start with the blue triangle. Let A be 28, let our hypotenuse be 100, and we solve for B. We get 96 for that distance, and we do it again with the little red triangle. Our hypotenuse is 35, and one leg is 28. You have 35 squared minus 28 squared, get a result, and then take the square root of that. Comes out to exactly 21. So all the way from L to M is going to be 21 plus 96. So LM, we go back up to the top and answer what they asked for. L to N 21. M to N was 96, and then whatever the other was. All right, so here we have a ship on the ocean. We went 6 miles north and traveled 4 miles east. Okay, so they want you to draw a picture of that. It looks something like this. He goes north, then he goes east from the dock. So where he's at now, there's a shorter straight shot back to the dock. And that's what we're trying to find. So our legs should be 4 and 6, and C would be the distance from the ship to the dock, which is what we're looking for. So A and B would be 6 and 4. So just based on that, A could be, B and C won't, because they're trying to say we know the hypotenuse. And D could be, but the problem is that on A, they have something about adding all the distances up to find out how far he is from the dock, and that's not what we're looking for. The dock is just distance C. Now we get into our 45, 45, 90s and 30, 60, 90s, and we just follow the steps and use a calculator, and it should work out pretty easy. On 45, 45, 90, like number 13, hypotenuse is the leg times the square root of 2. We know the length of the leg. A is our hypotenuse, so when we plug everything in, replace stuff from the picture, we end up with just 10 square root of 2. And that's probably how it's going to be left on the test. It probably won't be put in as a decimal, so you may need to compare some answers. 14 is also a 45, 45, 90, but it has a hypotenuse of 13 square root of 2. So when you replace hypotenuse with that, and leg, you can put either B or C, it won't matter because they're both the same. Divide by square root of 2 on both sides to figure out what C is. The square root of 2 is just cancel, and C is just plain old 13. And 15, we transition over to a 30, 60, 90 triangle. So the formulas change. Still need to label the sides. It's a little bit more important this time to label the sides. Well, the formulas here are the hypotenuse is equal to short leg times square root of 3. So our hypotenuse is D. Our short leg is 7. So that helps us find that piece. And then the formula for long leg is short leg times, uh-oh, I must have messed up. That's right, I messed up. Hypotenuse.
Short leg.
Yeah, short leg times 2. That's right. I got distracted, put the wrong formula up. So if the short leg is 7, the hypotenuse is 14. And the long leg will be the 7 square root of 3. Same sort of thing. Label the sides, write the formulas, and then replace stuff. So the hypotenuse is going to be short leg times 2, so the hypotenuse is 12, that gives the short leg 6. And the long leg would just be 6 square root of 3. 17, we go back to a 45, 45, 90. Hypotenuse will be 12. We can give the leg either M or K, doesn't matter. We're going to have to divide by square root of 2 on both sides. Now, I didn't make you, like I said before, I didn't make you rationalize the denominator on these, so you may get a decimal, but your answers on the test may not be the decimal you get, and it may not look like 12 over square root of 2. So you may need to punch some of the answers in your calculator and see which one matches up. Yeah, if M is 8.49, so is K, because it's isosceles. So we can't find the hypotenuse yet because we don't know the short leg. So we have to do the long leg, short leg formula first, and then come back and find the hypotenuse. And you've got to be careful when you put in square root of 15 divided by square root of 3. You've got to close the parentheses before you hit divide, or you can just hit square root of 15, enter, and then divide by square root of 3. But once you get that, that's your short leg, and your hypotenuse is always double that. But once you get the short leg, if you know short leg, the rest is easy. Double it to find the hypotenuse, times square root of 3 to find the long leg. I know that 2.24 times 2 is not 4.47, but I was going by the decimals, and the decimals rounded the first one up. All right, so we have a kite string now, making a 45-degree angle to the ground. You can't hardly see it down there, but they wrote it in as 45 degrees. So when we want the distance to the ground, we're talking about the altitude. We're talking about that perpendicular distance. So this is going to be another one of those isosceles triangles. And the kite string is 50 feet long from the kite to the ground. Okay, so the kite string ends up being our hypotenuse. And we're missing the legs. So here's the situation where we're going to get an answer, but it's not going to look like the answer choices. So our answer should be 50 over square root of 2. And none of those choices are there. So when you put that, it's actually equal to C, 25 times the square root of 2. 50 divided by the square root of 2 is the same as 25 times the square root of 2. You just have to put those in the calculator, figure out which one is going to match up.